Now let us start the next five problems of the final exercise 11.4. Here is the sixth question states that simplify secant a into 1 minus sine a into secant a plus tan a. So it's asking us to simplify this. Now let us multiply the secant a into 1 minus sine a. So secant a into 1, it is secant a minus, what is secant a into sine a? Let me write in a normal way first. So secant a into sine a and rest of the thing as it is secant a plus tan here. So secant minus, we know that secant a is equals to 1 by cos a. Let me substitute the value here. What is secant a? It is 1 by cos a into sin a. So thus into secant a plus tan a. So secant a minus 1 into sin a is sin a divided by cos a into secant a plus tan a. So secant a minus, what is sin a by cos a? Tan a. So secant a minus tan a into secant a plus tan a. So assume secant a as a and tan a as b. So this appears like the first part, a minus b into a plus b, which is a square minus b square. You know the formula. So what is a square here? Secant square a minus, what is b square here? Tan square a. And we know that from identity 3, sorry, identity 2, secant square a minus tan square a is equals to 1 from identity 2. So the value of it becomes, the value of secant square a minus tan square a becomes 1. So this is the problem. And when you simplify secant a into 1 minus sin a into secant a plus tan a, you end up with the value 1. So this is the sixth question. Now let us discuss the seventh problem, which is prove that sin a plus secant a whole square plus cos a plus secant a whole square equals to 7 plus tan square a plus cot square a. Here is the LHS part, sin a plus cosecant a whole square plus cos a plus secant a whole square. We are using the formula a plus b whole square, a square plus b square plus 2ab. Now let me substitute the values. What is a in the first part? Sin square a. B is cosecant square a plus 2ab. Sin square a plus cos square a. Let me write them in an order. So sin square a plus cos square a. And then let me write the other things. Cosecant square a, secant square a plus cosecant square a plus secant square a, and rest of the other parts, which is plus 2 sin cosecant. Last part is 2. We know that sin square a plus cos square a value is 1. So 1 plus cosecant square a plus secant square a plus 2 sin a into, we know that we can write cosecant a as 1 by sin a plus 2 cos a into, we can write the secant a as 1 by cos a. Both cos gets cancelled and both sin gets cancelled. So now you are left with 1 plus cosecant square a secant square 2. So here 1 and here 1 into 1 is 1, 2 into 1 is 2. So 2 plus here you are left with 2 as it is. So 1 plus 2 is 4 plus 1 is 5. So 5 plus secant square a. So till here there is no doubt, but from this step most of the student gets confused for the reason why you are using second identity and third identity purposefully. So I have an answer for that. In the RHS part, you can clearly see that the RHS part is in tan and cot, and we know that there is a connection between cosecant and the secant with both tan and cot using the trigonometry identities. And we know that the second trigonometry identity states that secant square a minus tan square a is equals to 1. From here, you get the secant square a as, if you shift the tan square to the other side, this becomes 1 plus tan square a. And the third identity is cosecant square a minus cot square a equals to 1. So you need cosecant square A. We shift the cot to the other side. This becomes cosecant square A equals to 1 plus cot square A. So we are changing it intentionally because in the RHS part, he has asked us to show it in the terms of tan square and cot square A. So that is the reason why we are changing the cosecant and the secant in terms using the identities, and we are changing them into tan and cot. So now we can write them as 5 plus what is cosecant square A? 1 plus cot square A plus what is secant square A? 1. So 5 plus 1 is 6 plus 1 is 7, and as per the RHS, the tan is on the first position. You can shift them. So 7 plus tan square A plus cot square A. So this is the RHS part. This is the RHS part. So therefore LHS equals to RHS. LHS equals to. So this is how you prove it. And if you have any doubt in this particular problem, you can ping it in the comment section. Now let us discuss the eighth problem. Simplify 1 minus cos theta into 1 plus cot square theta. Is asking us to simplify the problem here. So we can directly write it. So 1 minus cos theta into 1 plus cos theta. Like generally you need to write the given part, which is this thing, the complete entire thing again. Let me explain you directly. So 1 minus cos theta into 1 plus cos theta. This appears as A and this take it as B. So then this becomes A minus B into A plus B. So we have the formula for that, which is A square minus B square. Let me write it first and then we'll let you know about this thing. So you can write it as 1 whole square minus cos theta whole square into 1 plus cot square theta. And we know an identity which involves cot theta is third identity. The third identity states that cosecant square theta minus cot square theta equals to 1. When you shift the cot square theta to the other side, that becomes cosecant square theta equals to 1 plus cot square theta. Cosecant square theta equals to 1 plus cot square theta. Now substitute the values here. 1 square is 1 minus cos theta whole square is cos square theta into what is 1 plus cot square theta? It is cosecant square theta. So cosecant square, and we know that from identity 1, sin square theta plus cos square theta equals to 1. So what is sin square theta here? Sin square theta equals to, when you shift the cos to the other side, that becomes 1 minus cos square theta. So what is 1 minus cos square theta? Sin square theta. So sin square theta into cosecant square theta. Now sin square theta into, you can write cosecant as 1 by sin. So 1 by sin square theta. Both sin square theta gets cancelled. Now you are left with 1. So what is the value of 1 minus cos theta into 1 plus cos theta into 1 plus cos square theta? 1. So this is the answer. The next problem. So in the given data, he has given us secant theta plus tan theta equals to P. Then what is the value of secant theta minus tan theta? So he's asking us to find the value of secant theta minus tan theta. So we have an identity with both the terms secant theta and tan theta with this identity number. What identity number 2 says that secant square A minus tan square A, or else you can call them as theta, it's up to you, equals to 1. So let me write the identity here. Secant square theta minus tan square theta equals to 1. So these are like A square minus B square. If you take it as A, this becomes A square, minus if you take it as B, this becomes B square. So what is A square minus B square? A plus B into A minus B, the formula. So now let me write them as, what is A here? Secant theta plus what is B? Tan theta into secant theta minus tan theta equals to 1. So from the given question, what is the value of secant theta plus tan theta? It is P. So P into secant theta minus tan theta equals to 1. Now let us shift the P to the other side. The multiplication becomes division. So this becomes secant theta minus tan theta equal to 1 by P. So he has asked us to find the value of secant theta minus tan theta. So this is the answer. So therefore, secant theta minus tan theta equals to 1 by P. So this is the ninth problem. Now let us discuss the last one, 10th problem. The 10th question, it states that if cosecant theta plus cot theta equals to k, then prove that cos theta equals to k square minus 1 divided by k square plus 1. So you have multiple ways to solve this problem. Let me choose one. So we can write the cosecant theta. Let me write the values here. We know that cosecant theta can be written as 1 by sin theta, and cot theta can be written as 1 cos theta divided by sin theta. Now let me substitute them here. So the cosecant theta, which is 1 by sin theta plus cot theta, is cos theta divided by sin theta equals to k. So the denominator is same. So sin theta 1 plus cos theta, the numerator part will be 1 plus cos theta and the denominator part will be sin theta, which is equals to k. Now let me shift the sin theta to the other side. So this becomes 1 plus cos theta equals to k into sin theta. Now squaring on both sides. So when you square them up, 1 plus cos theta whole square equals to k into sin theta whole square. So what, let them be in the same way. 1 plus cos theta whole square equals to, when you split them, k square into sin square theta. So k square into sin theta whole square is sin square theta. And we know that from identity 1, sin square theta plus cos square theta equals to 1. So from here, what is the sin square theta? We shift the cos to the other side. So that becomes 1 minus cos square theta. 1 minus cos square theta. So here you can write the 1 minus cos square theta as, you can write 1 as 1 whole square. So this becomes a whole square minus b square. What is a square minus b square? A plus b into a minus b. A plus b into a minus b. Now let me write them in this way. So 1 square minus cos square theta becomes 1 plus cos theta into 1 minus cos theta. 1 plus cos theta into 1 minus cos theta. So here the 1 plus cos theta whole square equals to k square into, you can write this sin square theta as 1 minus cos square theta. From the derivation on the rough side part, you can write the 1 minus cos square theta as 1 plus cos theta into 1 minus cos theta. So 1 plus cos theta into 1 minus cos theta. So 1 plus cos theta gets cancelled and 1 plus cos theta gets cancelled. From here, 1 plus cos theta gets cancelled and the 1 plus cos theta gets cancelled. Now you are left with 1 plus cos theta equals to k square into 1 minus cos theta. Now let us split the values here. K square into 1 is k square minus k square into cos theta, k square into cos theta. Now let us take the like terms to one side. Now let me shift the k square to the other side. I mean minus k square into cos theta terms to one side and the constant values to the other side. So this becomes, here you have the cos theta already. Now I'm shifting the k square to the other side. The value that you have here is cos theta plus, and I'm shifting the k square to this side. So this becomes k square into cos theta equals to, here you have the k square already. So the one which is in positive, when it shifts to the other side, this becomes, so the one which is in positive, when you shift to the other side, this becomes minus. So k square, here we have k square minus 1. So here you can take the common as cos theta as common part. So here you are left with 1. 1 plus k square or k square plus 1, both are the same. So let me take the k square value first, k square, and now you have here is 1. So plus 1 equals to k square minus 1. When you shift the k square plus 1 to the other side, this becomes cos theta equals to k square minus 1 divided by k square plus 1. So this is the thing which is asked us to prove. Hence, therefore, cos theta equals to k square minus 1 divided by k square plus 1. So let me give you a clarification on this step again. There might be few students who might get confused. So let me write the 1 plus cos theta whole square, which is a plus b whole square. This part, 1 plus cos theta whole square. You can write it as a plus b whole square. We know that a plus b whole square can be written in a plus b into a plus b. So now we can write it as 1 plus cos theta into 1 plus cos theta. On the other part, you have 1 plus cos theta. So k square into 1 plus cos theta into 1 minus cos theta. So when both 1 plus cos theta gets cancelled, you will be left with 1 plus cos theta The thing is 1 plus cos theta equals to here k square. This got cancelled with 1 and you are left with 1 minus cos theta. The same thing you can see here. 1 plus cos theta equals to k square into 1 minus cos theta. So this is the problem. I hope you are clear on this problem. If you have any doubts on this last 5 problems of the exercise 11.4, you can comment in the comment section. Thank you. Have a great day. Please do like, share and subscribe.